Welcome to another tutorial on the pD2 value calculation. In earlier video we have done with the PA2 value calculation, and now we are going to deal with the pD2 value calculation. pD2 value, the definition of it is the potency of a drug may be expressed by the pD2 value, which is defined as the mean negative logarithm of molar concentration of the drug producing 50% of the maximal response. So by definition you have to remember this particular value. This particular value will be really important to us, that is 50%. As whenever we will draw the graph, we are going to interpolate from y-axis value, that is 50%. We are going to take y-axis value, that is 50%, and then interpolate it to the base fit line, and from that we are going to extrapolate it to the x-axis, so that we will get a log dose value from the x-axis. So let's see how the calculation we do with this. So always there will be a question in the exam, that is calculate the pD2 value of a non-agonist drug from the given data. So a certain data will be given, a stock solution concentration of unknown agonist drug, then molecular weight of that agonist drug, and bath capacity of the organ tube. So if you see the data which is given over here, two of the columns they are blank, and in two columns some data is given. So see, the first column is dose of agonist, second column is concentration of agonist, third column is response height, and fourth column is percent response height. So we are supposed to calculate the concentration of agonist, for which we require this data, that is the stock solution of concentration of unknown agonist is 20 microgram per ml, and percent response height, you know how it is to be calculated, that let's see next slide. So concentration of agonist, you have to just multiply the dose of agonist with that of the stock solution concentration, and in this case the stock solution concentration is 20 microgram per ml. It is 20 microgram per ml. So if the dose is zero point 0.1 ml, if we are taking, then you have to just multiply it with the 20, so you will get the value, that is 2. Okay, so likewise you have to do it for the all the other doses. So percent response height, simple. If the uh, see, in the denominator you have to select the maximum response height, that is as per the table. In this case it is, I guess, 44, and you have to, if you are calculating it for the point 1, the response height was something 17, so 17 divided by 44 into 100, so this will give you the percent response height. So this same thing you have to do for all the subsequent doses. For the last dose, of which the response height is 44, but obvious is that the percent response height of this, that dose will be the 100%. Okay, so the final table becomes, you see the dose of agonist and concentration of agonist. So this is, these values you get after multiplying these values by the stock solution concentration, and these values you get after dividing this value by maximum response height, that is 44, and multiplying it with the 100. Okay, so all these values you will get after that. So you can see for this last value, that is 3.2 dose, the percent response height is 100%. So how to draw the graph? You have to first of all label the graph. On y-axis you have to uh, give the label as the percent response height, percent response height, and in case of x-axis you have to give the label as log dose. Okay, so you have to plot all the points on this, and you will get a line like this. I'm not plotting the actual points, but I'm showing you will get a line like this. And once you get a best fit line is the line which uh, contains maximum number of points, minimum number of points through which a line should pass. It is 2, or all the points can be there on the line, but in real life it is very less likely that all the points will lie on the line. So in this case what you have to do, as I said, the 50%, uh, the number from the definition is very important. So on y-axis you have to locate the 50% value. From this point you have to interpolate, one second, you have to interpolate onto the line, and from there you have to extrapolate onto the x axis value. So you whatever value you will get, it will be a log dose value. So what is to be done now? The actual calculation of the pD2 starts. Okay, so what to do in this case? You have to take an antilog of the log dose value that you have just got in the graph. So first step is the taking the anti-log. Okay, whatever log dose value you have got, we have taken a log, anti-log of that log dose. Okay, so once we get that value after taking the anti-log of that log dose value, we have to calculate the EC50 value. So how to calculate the EC50 value? It is very simple. EC50 value is equal to whatever value we have got over here. Let's assume it as x. Okay, so this x divided by bath capacity. Okay, what is the bath capacity over here? In the given data it was given as the 20 ml. Okay, and this x value is in micrograms. Okay, so whatever EC50 value we have just calculated, it has the unit that is microgram per ml. So what is to be done next? We have to convert this microgram per ml EC50 value into molar values. So how to do that? We have to, so let's assume that this value, EC50 value, that is x by 20, let's assume it as okay, somewhat let's assume it as it is y. Okay, so whatever value we have got over here, it is y. Okay, so how to convert it into the molar values? So EC50 in molar values is equal to y divided by the molecular weight. Okay, so in the given data it is also given the molecular weight of the agonist. You have to divide this value by the molecular weight of the agonist and multiply it with to the 10 is to minus 3. Okay, so after you get the molar concentration value, let's assume it as the molar concentration value of the EC50, it is Z. Okay, so now how to calculate the pD2 value from the molar concentration value of the EC50? The formula is pD2 is equal to minus log of EC50. Okay, but we know that the EC50 is equal to y divided by molecular weight into 10 is to minus 3. Okay, so we have considered it as the Z. Okay, so pD2 then becomes minus log of z. So what will happen with the 10 is to minus 3? We have to take this minus 3 to this side. Okay. So pD2, the final formula for the pD2 becomes 3 minus log of z. Okay. So z is what? Z is y divided by molecular weight. And what is y? Y is x divided by the bath capacity. Okay, and from where we get the x? We get the x by taking antilog of the log dose value that we have got from the graph. Okay, so simple. You have to first of all do the calculation, that is you have to determine the concentration of the agonist, and second column you have to calculate, that is percent response height. So you have to then draw a graph, that is on y-axis percent response height, and on x-axis you have to label it as log dose. So you will plot the points, then you will get a best fit line, and from y-axis value, that is 50%, you have to interpolate it to the base fit line, and from that you have to extrapolate it to the x-axis. So you will get a log dose value. Take antilog of that log dose value, then you will get the value, that is x. So from that x value, whatever x value you have got, you can calculate the EC50. So EC50 in microgram per ml is x divided by the bath capacity, that is 20 ml. So consider it as a y. So whatever y value we have just got, we have to convert that. It is in the microgram per ml. It has that particular unit, that is microgram per ml. We have to convert it to the molar concentration. So we how to convert it? By dividing it by the molecular weight of the agonist, which is a given data, and multiplying it with the 10 is to minus 3. Okay, so considering this y divided by molecular weight as the z, so how we can calculate the pD2? pD2 is equal to 3 minus log of z, and z is nothing but the y divided by molecular weight. So this is the simple calculation of the pD2, with which you can calculate the pD2 value. And as you know, the pD2 value indicates the potency of the agonist. Okay, so that's all for the calculation. It is very simple calculation. Hope that this particular video will help you. I know there are some mistakes, not in the calculation, but a few mistakes you may find here and there. I hope you will ignore those mistakes and focus on the calculations which I have just taught. If you have any questions, any queries, any doubts, then you can post your queries and doubts in the chat box. And thank you for watching this video till this time. Thank you.